those who have been with me in the last lesson, I went through the necessary condition for an equation to have only one real root, and also if the condition is not satisfied, how it can still have a real root. I took an example. So today we use the Newton-Raphson formula. Incidentally, sometimes they ask you to prove this. It's very simple. If x equal to alpha is an approximation to the root of f of x equal to 0, then x equal to alpha minus f of alpha over f dash of alpha is a better, is generally, therefore they say is generally a better approximation. That is what Newton-Raphson's method says. In case you are not asked to prove this formula generally is in the formula book, you can use it. Otherwise, I'll show you how to prove it. Sometimes they say, show that if x equal to alpha is an approximation to the root of blah blah blah, x, or sometimes xn plus 1 equal to xn minus f of xn over f dash of xn. They will say the same thing. To understand this, let's look at, we use a graphical method. Let's say this is the function f of x. That's the actual root, correct? Let's assume alpha is an approximate root there, correct? Alright? Now, do you agree? If I were to join that, this particular length is f of alpha. Yeah. Now, let's draw the tangent at that point. This pen is dried up. This is the tangent. Let's say this at x1. Okay. Now, what's the gradient of tangent? Gradient of tangent equals gradient of curve at x equal to alpha. So, which is f dash of alpha. What's gradient of tangent? Change in y over change in x, right? So, that is f of alpha over alpha minus x1. So, what is x1 equal to? Or I can say alpha minus x1 is f of alpha divided by f dash of alpha. So, x1 equal to alpha minus f of alpha over f dash of alpha. That is a better approximation. As you can see, look, between the root and alpha, the gap was that much. Between x1 and the root, the gap is much smaller. So, x1 is a better approximation. This is, they expect to see the diagram, they expect to see this working, and that answer. Yeah, I think 2 or 3 marks, not more. So, let's do, that is Newton-Raphson's formula. I'll leave the formula there. I will take some example, the same example to show you. As usual, I forgot to start the stopwatch. I'm becoming very clever these days. Stupid, I should say. Me, not you. Because I should have started. Now I started the clock. Remember the equation we did. X cubed plus 2x squared minus 4 equal to 0. I use xn plus 1 is 4 minus 2xn squared power 1/3. I started with x naught equal to 1.15. Yeah? And I found even when I did up almost up to x8, the roots were not coming close to each other. Yeah? So, whereas, let's look at this. Use Newton-Raphson's method to find an approximation to the root of x cube plus 2x squared minus 4 equal to 0 that lies between 1.1 and 1.2. I would say starting with x equal to 1.15. I hope that works. 1 plus 2 is 3, 3 minus 4 is negative, 2 cube is 8, 8 plus 4 is 12, 12 minus 4 is 8. Oh, 8 plus 8 is 16, minus 4 is 12. So there is a root between 1 and 2. So that's okay. So what we do is, this is how you show the method. F of x equals x cube plus 2x squared minus 4. Look, only when it is algebraic, do it this way. If it is not algebraic, just do f of x over f dash of x, as I'll show you in the next question. So f dash of x equals 3x squared plus 4x. So you say x equal to x minus f of x over f dash of x. Simplify that. This is xn plus 1. So xn plus 1 equal to 3x cube plus 4x squared minus x cube minus 2x squared plus 4 over 3x squared plus 4x. What does it become? 2x cube or 2xn cube, 4 minus 2 plus 2xn squared plus 4 over 3xn squared plus 4xn. That's xn plus 1, right? So I've used Newton-Raphson's method. X minus f of x over f dash of x, that's what you do. Keep the left hand side as xn plus 1 so you don't get confused. Simplify into a single fraction, then stick an xn wherever you have an x. Okay? Having done that, let me write the formula. Where shall I write it? Shall I write it here? Okay. So, first substitution you show x naught is 1.15. So, x1 equal to 3 times 1.15 cube plus 2 times 1.15 squared plus 4 over 3 times 1.15 squared plus 4 times 1.15. Correct? 3x cubed plus 4x squared minus x squared minus 2x squared. So 2x cubed plus 2x squared plus 4. Yeah. So let's use a calculator. Find the value. Keep the working as it is so you can use the answer later with brackets. Yeah. So you open a bracket. 3 times, I need my glasses so that I don't go wrong. 3 times square, isn't it? Open a bracket. 1.15 close bracket cube plus 2 times 1.15 squared plus 4 close bracket divided by open bracket 3 times 1.15 squared plus 4 times 1.15 close bracket equal to 1.3082. I'm going to keep the complete calculator value. So what I'll do is, this is what I do. So I will say 3 times, for x2, I will do 3 times answer cube plus 2 times answer squared plus 4 divided by 3 times answer squared plus 4 times answer. You understand that? That's what you do in your calculator. 3 times four times answer, then 3 times answer squared, then in the top it is 1.15 is it? Okay. I need 2 times answer squared, and then 3 times answer cube. Three times answer cube plus 2 times answer squared plus 4 divided by 3 times answer squared plus 4 times answer. 1.3639. Let me just show you here. X0 was 1.15, X1 was 1.3082, X2 is 1.3639. Put equal to X3 is 1.3892. Put equal to X4 equals 1.40410.7 equal to X5 equal to 1.4078 equal to X6 equal to 1.4109, X7 equal to 1.4125. I think it'll come in X8. X8 is 1.4133, it's almost there. X9 is 1.4136. Sorry, V8. X10 is 1.4140. X11 is 1.4141. X12 is 1.4141. There I went up to 15 and I was still not getting anywhere near. So I've got two answers that are identical. So x equal to 1.4141 is the rule. That is how you apply Newton-Raphson's method. I will take another example to show you. I've done only 8 minutes. So I will leave that formula there. All right. Now, this is my question. Okay. Show that the equation e power x minus 4x equal to 0 has two real roots. Okay. Find an interval of the type a less than x less than a plus 1, where the smaller of the two roots lies. using x naught equal to a plus 1 over 2, use NR method, I don't want to write everything, method to find this root correct to 3 decimal places. That would be a typical A-level question. Yeah? First and foremost, how will you, of course, if there is only one real root, there is a method. Now you have to show 2 real roots. Remember, I mentioned this in passing in the last lesson. Split the given equation into 2 convenient graphs. Yeah? So therefore, e power x minus 4x equal to 0 can be written as e power x equal to 4x. So, draw the graph of y equal to e power x. Draw the graph of y equal to 4x. There are 2 points of intersection. So, from the graph, because remember e power x goes much faster than 4x, there are exactly 2 points of intersection. Therefore, 2 real roots. Should we do the other one? E power x minus 4x over e power x minus 4. X minus e power x. Let's find for the larger root. Because smaller is very obvious, okay? You know it's obviously more than 1. So what is f of 2? E power 2 minus 8. 27 squared. What's 25 squared? 625. 22.7 squared. Okay, let's do that. Alright. E power 2. Shift ln 2 minus 8 is negative. Minus 0.06109. What is f of 3? E power 3 minus 24. Correct? No. 12. What's e power 3 minus 12? Shift ln 3 minus 12 is plus 8.08. So therefore, you have 2 less than x less than 3. So x naught is 2.5. So far so good. X naught as a plus 1 over 2. 2 plus 2 plus 1 over 2 is 2.5. I must use Newton-Raphson's method. Very good. So therefore, what is Newton-Raphson's method? F of x is e power x minus 4x. F dash of x is e power x minus 4. So, xn plus 1 equal to xn minus f of xn, e power xn minus 4xn divided by e power xn minus 4. If you want to, what I would do is, I would do it directly. So it's 1, so x1, x naught is 2.5, right? So x1 is 2.5 minus e power 2.5 minus 4 times 2.5 divided by e power 2.5 minus 4. Okay. Let's do that. (2.5) minus, open a bracket, shift ln 2.5 close bracket minus, oh, I need to put two brackets there, minus 4 times 2.5 close the first bracket divided by open second bracket, shift ln, that's e power 2.5 close bracket minus 4 close bracket equal to 2.233. I wanted 3 decimal places. So 2.233. Now, the same story, wherever you have 2.5, write answer. It will take me a minute, hopefully. Answer minus e power answer minus 4 times answer divided by e power answer minus 4. So just to make you understand, so I'll say x2 equal to answer minus e power answer minus 4 times answer in brackets over e power answer minus 4. I hope that's what I have. Answer minus e power answer minus 4 times answer divided by e power answer minus 4. 2.159. Put equal to 2.153. Put equal to 2.153. Look, within 4 applications, I got the root. Remember, you stop when the root is correct to the required accuracy. So x equal to 2.153 is the root. Suppose, let's say, they said, show that the root is correct to 4 decimal places. What would you do? So last bit I didn't write, now I'm going to show that the root, show that x equal to 2.153 is a root correct to 3dp. Your f of x is e power x minus 4x. So find f of 2.1525, then f of 2.1535. What's f of 1.25 and 1.35? Because boundary values, remember GCSE. So that would be shift ln 2.1525 close bracket minus 4 bracket 2.1525 close bracket is minus 0.0036. I'm not interested. The other one is 2.1535. See, this is the advantage of you people using a calculator. You can just keep deleting and changing it. Is 0.000958. So look, there's a change in sign, and you have taken that boundary values of the interval, therefore root correct to 3 decimal places. That's how you show it. So to recollect, everything we have done at iterations. To locate a root, look for a change in sign. You must show there is a change in sign and conclude there is a root. Next, to find iteration, you will have to rearrange the given equation in the form x equal to f of x and then put n and n plus 1. So iteration is a process where you keep repeating the same formula. Hello, I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.